Hi everyone. In today's lesson, we're going to look at 8C on modelling linear growth and decay. So this is building on our sequences work from last lesson. Now, linear growth or decay, if we recognise this, first of all, linear means that we've got a straight line happening, is talking about when an amount increases or decreases by the same amount in regular intervals. And so there's two key examples that we'll use to look at this, and that is simple interest, which is also called fixed or float rate interest, and depreciation of the value of a new car. In looking at this then, if we recall from last lesson, whenever we were creating sequences, we would have VO, which was always the initial amount, and then we would have another rule. So it said Vn plus 1 equals the previous number, I don't know, plus 5. That would be a sequence that's increasing by 5 each time. So when we look down here this time, we've got this plus D on the end here, and this indicates that we're modelling linear growth because we're adding something on each time. Or our rule can have minus D, which is modelling linear decay, because we would have it decreasing each time. And in both cases, D actually comes from taking a rate and multiplying that by the initial amount, and that will give us the rate of growth or decay. So we're going to look at these examples in turn. If we look at simple interest, you might remember simple interest for when we looked at finance last year, and simple interest can be in the case of an investment or a loan. So if it's an investment, it's when you invest money, i.e. you pop your money into a savings account with the bank, and a fixed amount of interest is paid into the account after regular time periods. So maybe you've got an account with a 4% rate each year, and you get that interest at the end of each year. A simple interest loan, that's when you're borrowing money from the bank, and because you're borrowing money from them, they're going to charge you for having that money. So they're going to have a fixed amount of interest that's charged at regular time periods. And we use this word principal to be the initial amount that is invested or borrowed, which would therefore be our VO amount in this case, because that's our initial amount. So if we are looking at a recurrence model for this, the rule then for simple interest is this one here. So VO is the principal, and then because simple interest is linear growth, we're using that Bn plus 1 equals Bn plus D. And D is found by taking the interest rate and timesing it by the initial amount, because that rate is calculated on that initial principal, and you're getting that D amount of interest added into your account each year. So yeah, the Vn then will give us the value of the loan or the investment after n years. So I have two problems for us that I want us to go through today. The first one here, it says $3,500 is invested in a simple interest account at 3% per annum. And there's a few steps that we want to do. A says we need to model this investment using a recurrence relation. So it wants us to set up a rule. Now, first of all, we know that our principal VO is at 3,500. So I'm going to make a little note of that. But I need to work out what D is first of all. So remember, my rule for D is R over 100 times the initial amount. So this is how much interest is getting added into the account each year. And it's at a rate of 3% per annum. So here I'm going to put 3 over 100 and multiply that by 3,500. And so if I open up my calculator here for us and type this in, 3 over 100 times 3,500, and it's $105 of interest that's earned each year. So now when I'm creating this rule, I'm going to have here VO equals 3,500. So that was the initial amount. And then my rule for the next year comes from taking the previous year VN and then adding on that $350 there. That's my answer now for part A. Part B wants me to work out how much this investment is worth after 5 years. And now for me to do that, I need to actually do this on my calculator. And so remember before the holidays, we looked at how we could put things in our calculator. So we'd enter in that initial amount of, 3,500 and I press enter. And then if I add on 105 and press enter, at the end of my first year, I've got $3,605. And I can do that again a second time, third time, fourth time, fifth time. So at the end of the fifth year, my investment is therefore worth $4,025. Now, the question here wants us to create a graph of the first 5 years of the investment. So I might also, let's just jot down those other numbers for us too. So year 1 was 3605, year 2 then is 3710, year 3 is 3815, that's a 3. And year 4 is then 3920. To make this easy for us, let's just draw this graph on our calculator in our statistics menu again. So let's come back here and we can put in list 1 our years. So year 1, year 2, year 3. Oh, sorry, we'll start at 0 to put in the initial amount, and then 3, 4, 5. So the initial amount we had was 3,500. Then I could do 3605. 3710, 3815, 3920, 4025. And now if I go set graph settings, let's make this a line graph. And I can see here that I've got this nice straight line that is formed with those values. I could then sketch that as well. So let's just enter this down. I could sketch that myself, but let's take a screen grab and paste it in here for us. And I could just label the features on here for us so we knew that this here is 3,500, and I've got 0, 1, 2, 3, 4, 5. So this down here is years, and over here is investment dollars. Fab. So that's then C. D wants to know, after how many years will the investment be worth more than $4,500? I'm not sure what's going on with this inking here. So if it wants to know when it'll be more than 4,500, if I go back to that main menu, remember at the moment we're at year 5. So because this one's happening quite quickly, I could just keep counting. Year 6, year 7, year 8, year 9, year 10 is when it's now gone over. So it's taking 10 years for the investment to be worth more. Okay, so that is our first example there. Okay, if we now look at our second example here for us, this one now says that $18,000 was invested in bonds, paying simple interest at a rate of 3.4% per annum. So again now, $18,000 is our VO amount and 3.4% there, that is our rate. So it might be a good idea when you've got these questions to label your variables down really quickly to help you remember what they are. We need to express this using a recurrence relation again. So remember, we need to find that D value first, and that comes from taking the rate, dividing by 100, and then timesing that by 18,000. So again, now if I pop this in the calculator, I get a value of $612. So what that is telling me is each year this investment is earning $612 in the account. So if I write the rule here now, VO is 18,000, and then Vn plus 1 equals Vn plus 612. Now, part B wants me to find the value of the investment after 1, 2, and 3 years. So let's just write down 1, 2, 3 for us. And if we come back to the calculator here, remember I can now type in 18,000, and then if I press plus 612 and press enter, that gets my first year. If I keep pressing enter, it keeps repeating the recurrence relation for me. So 18,612 19,224 and 19,836. Now, with all of these, because they are money, I always need to put a dollar sign at the front. That is my unit, so make sure you always include that. And the final question here, it wants to know how many years will it take for it to be greater than $20,000. Let's just keep counting here. So if I press enter again, this is 4 years, 5, 6, 7. We're at 22,284. So it's taking 7 years. We always want to be giving this as an exact answer there. So yeah, just keep entering down until the number is bigger.